In this third video on trigonometric graphs, we are going to be looking at some trig transformations, but we're going to be applying our thinking and recalling some facts from parabolas and quadratic functions. Okay, let's first just draw our regular sine graph. Okay, so here's our regular sine graph. The important points are 360 degrees, a minimum at 270 degrees, and it cuts the axis at 180 degrees, maximum 90 degrees, and it starts at 0 degrees. We've got a maximum value of 1 and a minimum value of minus 1. If you were ever asked to draw or sketch y equals sine x, this is exactly what it should look like, if not even neater. So here's y equals sine x degrees. If we recall back to our work on parabolas, let's imagine this is a graph of y equals x squared. So it is a happy parabola. It is sloping up the way. That means the number in front of the x squared is positive. It's symmetrical about the y-axis. If you recall back to a previous video on quadratics, if we were asked to graph y equals x squared plus 3, all that would happen is that these points would shift up 3 places. So instead of having a minimum turning point at 0, 0, it would just move up 3 places. And this would be 3, 0. And this would be the graph of y equals x squared plus 3, for example. If we added on 3, our graph would move up 3 places. If we subtracted 5, it would move down 5 places. The same is absolutely true for trigonometric graphs. If we are asked to graph y equals sine x degrees plus 2, let's imagine that's what we're looking to graph eventually. Y equals sine x degrees plus 2. Okay, so if our usual graph starts at 0, it is in fact going to start at 2. Because it's just everything, basically all these points are going to shift up 2 places. Where the points occur is still going to be on the same point on the x-axis. So we're still going to have a maximum at 90 degrees. It's still going to cross at 180 degrees, but it's just going to be shifted up the way by 2. So it starts at 0, so it's going to start at 2. We've got a maximum of 1. We're going to add 2 onto that, so that means we're going to have a maximum of 3. And that should be all the points that we are looking for at the moment. How I like to draw these is I kind of like to think of it as a dot to dot. And I'll explain what that means. So if we're starting at 0, added on 2, this is where we're going to start. If we've got a maximum of 1 at 90 degrees, if we add on 2 to that, we're going to have a maximum of 3 at 90 degrees. It cuts the x-axis at 180 degrees, so it's at 0, but we need to add on 2, 1, 2. Minimum of minus 1, we need to add on 2, 1, 2. And we'll stop up here, adding on 2. And then we just need to draw it as normal. Okay, so I've just done that there in my own time. Obviously it doesn't look as fancy and as refined as this graph here, but I'm doing it on a tablet, so I hope you can just understand the general idea that if we have got a regular y equals sine x, if we are asked to graph y equals sine x plus 2, we simply just shift every point on the graph up 2 places. And so here is my graph for y equals sine x plus 2. The same applies for like cos x. If we were to do cos x take away 3, we would just have to shift the cos graph down 3 places.